joining this meeting, this webinar. Can you hear me?
Yes, I can hear you.
Okay, so thank you for introduction. I'm Yuuya Koduka from ASICS. The title is Human-Centric Science Approach to Footwear Design. So this is agenda of my presentation. So first, we want to introduce our design philosophy. The second one is why we need AI. The third one is why we collaborate with RebuilderAI. The last one is the trial result of VRINGON for generating the 3D data of foot shape, shoe shape. So this is ASICS. So ASICS is a sports company. So this keyword is based on the Latin expression. So anima sana in corporate sano. This is the roots of ASICS. So this keyword means you should play for a healthy mind in a healthy body. So based on this, so this is our corporate philosophy. My corporate philosophy is sound mind, sound body. This is important factor for designing the shoes product. So we have some sports science building. So I'm in Japan, Kobe. So in this building, so we can make the unique material and we can sewing and we can make the 3D printed product. After then, so we can get the hearing from the athlete. So manufacturable 3D data is most important for us to make the 3D real sample. This is shoes list for designing us. So we want to design the marathon, soccer, running, tennis, and sandal. So we want to construct 3D data for designing the so many product. So our design philosophy is only one. So my design philosophy is a human-centric design. So this means that product design based on the human response. So to evaluate the human response, we have two key technologies. First one is a motion analysis system. So this analysis can evaluate the running motion and the ground reaction force to evaluate the motion response. The second one is a structure analysis like this. So we have construct a virtual human model to evaluate and predict the functionality before making the sample. So based on this analysis, we can design the so many shoes for improving the performance. This is an example for making the shoe sample. So shoe designing, we can evaluate and design the so many high performance shoes, especially long run, marathon, and sprint, and so on. So for improving the performance for athletes, we need improve the design like this. So in this case, for athletes, so functionality is the most important factor for designing and selecting the shoes. So, but on the other hand, for casual users, for athlete, so functionality is most important. But so for casual users, so great functionality is not enough. So we need to consider the not only functionality, but also appearance preferences. So based on this concept, so we want to design the innovative product for serious athlete and for casual users. So this graph shows the range of design space. So this axis means the appearance. This axis is the functionality. The blue point is a current product. So for serious athlete, we need to improve the functionality like this. So on the other hand, for casual users, so for casual users, want high design excellence, keep the functionality. So to design innovative product, we need to consider both concepts. So based on this, we want to construct a design system considering the functionality and appearance preference. This is objective design process. So first we input the concept of design. Based on this concept, we want to populate the 3D data like this. After generating the 3D data, we need to simulate to evaluate functionality. So we can get the functionality map like this. So this axis is also appearance functionality. So based on the simulation, we can evaluate the function before making the sample. After making this map, we can evaluate not only appearance, but also functionality. So in this case, so red one is the most important for serious athlete. On the other hand, so blue one is very, very important for casual users. So to construct a design system, so we have construct the algorithmic design-based 3D modeling as a current process. So we want to introduce this process. So first we input the concept of design space. Then we need to define the parametric modeling. In this case, we need to define the parameter of landing shoes. So in this case, we define the thickness, angle, and distance as the parameters. So we need to construct the algorithm for generating the 3D data of shoes. After generating the algorithm, so we can generate the 3D data like this. So the advantage of this 3D modeling. So if we change the parameter like this, so we can generate so many 3D data based on this algorithmic design. So this system very, very useful for us. So for generating the multiple CAD data, so we need to time-consuming and require high-level mechanical engineering knowledge to modify the specific 3D data. So we can't change non-parameterized area. So in this case, so if we concept change it, so everything has to read down. So to achieve this challenging point, so we want to update design process as a future plan. So this one is the requirements of future design process. First, we want to consider the 2D or 3D data can be generated quickly and easy from the design concept. So second one is easy and flexible shape modification by designers and engineers. So last one is a flexible process that can adapt to concept changes. This is future plan for generating the shoe designing. So first, as the aspect of designers, so we input the concept design. Then, so we need to populate the images. After that, we need to check the design by designers. This is the first step. So as a second step, based on this data, so AI can generate the 3D data like this. After generating the 3D data, we can evaluate the functionality like this. After simulation, we can check the functionality is enough or not. So if enough functionality is enough, we can go to the manufacture process. But so if functionality is not good, we need to change the 3D data like this. So our motivation is construct a design system. It can easy to change when the concept changes. So this graph, this figure shows the why we collaborate with RebuilderAI. So yellow one can apply by VRINGON. So that's why we collaborate with RebuilderAI for generating the 3D data of shoes sole. The last topic is a trial result of VRINGON. To generate the 3D data, and 2D data, we use a VRINGON. This is an example for sketch to the image like this. So if we input the design sketches, then we can generate the multiple 2D images like this. So VRINGON can generate not only 2D data, but also the 3D data like this. So if we input the multiple angle images, then VRINGON can generate the 3D data like this. VRINGON can generate and add the ASICS logo like this. If we input this shape without logo, VRINGON can generate like this with ASICS logo. So logo shape is most important for checking the design, but VRINGON can generate the right shape of logo. The other function is the fusion function. So if we input the shoes and sole images, then VRINGON can generate the fusion 2D data like this. So after function of VRINGON can generate the new structure like this. If we input the prompt and images, VRINGON can generate the impactful shoe shape like this. VRINGON can generate 2D and 3D data, but also we can make the real sample like this by using the 3D printer. So this is summary of my presentation. So our corporate design philosophy is a human-centric design. So based on the human-centric design, we need to consider the functionality and the appearance preference. So to create concept designs that drive innovation, so we want to use an AI-based generator. So why we collaborate with RebuilderAI? So collaboration to realize the ideal design flow from concept design to functional design. That's all my presentation.